Time we learn to work with systems of equations with graphing. This is a method where we take equations, graph them, and find the point of intersection, which is going to represent a solution to the system. Before we get to that, let's review graphing a line. When you're graphing a line, you need to have an equation that is in slope-intercept form. At least that's the easiest way to do it. And you'll have your slope and your y-intercept. And based on those two facts, you'll be able to graph y equals 2x plus 1. We'll find our y-intercept and we'll put this orange mark on it, and we'll have a slope of 2, meaning we'll rise 2 and run 1, which puts us roughly right there. And we connect those two, and you end up with a line that looks roughly like that. Very roughly. Now, when you learn to, what we're going to do in this section is we're going to learn about when we have another line that is on there. This would represent another linear equation. We're going to learn how this point right here where they intersect represent the solution. Right, so let me go ahead and give you two equations, and I'm going to give you two linear equations, and we will go ahead and solve that with graphing. Now, it is worth mentioning that graphing is just one of the ways to solve systems of equations, but it's the first one because this will give you a visual appreciation for what exactly it is that a solution represents. Okay, so we're given 2 points, and actually I need to put a couple of dashes right there. We're given 2 linear equations, y equals x plus 1, and we're also given y equals negative x plus 5. So let's go ahead and graph both of those. We have the y-intercept of 1 and a slope of 1. So for the first equation, which is green, we're going to have a point there with a slope of 1. So it's going to be roughly right there, and we're going to put a line through it like so. And let's have that line just represent what we have there. Now, the next one, we're going to have a point on this second equation at the point 5 with a slope of negative 1. So we're going to go over 1, down 1. So we're right there. And let's connect those two. All right. Now, I've graphed those two. Now, again, I'm going to ask, what does that point right there where those two lines intersect, what does it represent? Well, it represents an x and a y value that is going to solve both of these. This point equals x and y that works for both equations. Or can solve both equations. And when I say solve, it means exactly what it sounds like. It's going to work. When I plug in the y for both of these and the x for both of these, it's going to work. So let's take a look. This point looks like it's going to be roughly, very roughly here because my graph isn't perfect, but it's going to be about 3 and 2, I believe. I believe that's going to be x value 2, y value 3. Now my graph isn't perfect here. It's not. But that's okay. What that means is we're going to plug it in. So does 3 equal 2 plus 1. So I'm just moving this over here and I'm plugging in the values, and it does equal that. Okay, let's move this one over. Does, let's see, 3, does 3 equal -2 plus 5? And yes, it does equal. That is 3. So what you just seen there was that I graphed this equation, and you could use desmos.com to get more exact graphing going on, or graph paper. And I use that to find the solution. Now, what's very interesting about all of this is that almost any equation or almost any system of equations will have this one point where an x and y will satisfy it. But there are exceptions. Okay, let's talk about what those exceptions are. Let's go ahead and in blue here, let's write it out. What are the exceptions? Well, actually first, what do we have here? What is this situation? This is one solution. One solution. There is exactly one solution for this system of equations. Now, we're going to go to the red mark. Now, let's go red. There's a situation where there is no solutions. No solutions. No solutions. Now, that system, when there is no solutions, is when you have a situation where it is. Actually, let's go -2 and up. Okay. Now I just drew that red line, and what that red line represents is y equals, it has a y-intercept of -2, but it has an identical slope to our green line, which is a slope of 1. So y equals x minus 2. Now, what that represents is, or what that tells you is that a system will have no solution when it is two equations with identical slopes and different intercepts, because those lines are going to stretch on infinitely on that same slope. So they're never gonna intercept there. And there's one last type. Let's go back to blue here. There's one last type, and that's infinite solutions. Infinite solutions. Now, you have infinite solutions. What you're going to see is there's often going to be things where it's kind of hidden. So it'll be -2 equals x x minus y, no, x plus y. Wait a second. So it'll be hidden. It'll be something like, let me think about this. It will be hidden, let's see, like, so they'll take, let's say, -x plus 2 equals -y. Okay, yeah, it'll take something like that. This is what you'll often see. It will be this, in this different form, but if you were to, right, because linear form is not -y, it's positive y. So you need to divide by the coefficient of y. -y is -1, so you need to divide every term in this linear equation by -1, and you get x minus 2 equals y. which in fact is the same thing. So what it does is it overlaps. It overlaps that red line, meaning these two are a system, and they share infinite solutions. Every x and y value within that line will satisfy the system. So that's the three possible solutions. Now, the thing about graphing systems is that it's not perfect, particularly if that intercept point, this here, is fractional. You can't look at a graph that doesn't intercept at an exact point and find the solution. Secondly, graphing can be a little tricky. You can get a little mixed up. So it's important that you always, as I did, sub back in and find your solution that way. Make sure that what you think you found is actually accurate. In the next video, we're going to solve systems without graphing. We'll start by using substitution, and then we'll move to elimination. But first, let me put up a set of practice problems for you. I'm going to put up I'll put up 2 problems at a time. Let's get to it. Okay, here are 2 questions for you. Question number 1 in green asks you to graph and solve. Actually, go ahead, pause the video, try these 2, then we'll work through them. Okay, the first question in green asks you to graph and solve. Let's do it in that order. Let's go ahead and graph it and solve it. Again, what we're looking for is a solution of systems. That is, an x and a y pair that are going to satisfy both equations. Right. The first equation has a slope of 1 and an intercept of 2, y-intercept of 2. So we're going to be here, and we're going to have a slope of 1. So we're going to go over 1 and up 1. So we're going to be roughly there. And now we're going to connect those 2 lines. Okay. Let's go ahead and go orange for the next one. Or I think it would be better to go green. Sorry, blue. Now we have an intercept of 4 and a slope of -1. So we're going to go over 1, down 1. Okay. I'm going to go ahead and draw a line just for the sake of it. We can do better than that. Let's go here. And let's actually try one more time. It's just not looking great for me. Good enough. But the interesting thing about this one is that it put us on an exact point because we had this slope of 1 up and 1 down with a separation on the y-axis of 2. So interestingly, it gave us the exact point of, look here, x value of 1 and a y value of 3. 1 and 3. And now we can plug this in. Does 3 equal 1 plus 2? And we know it does. And again, does 3 equal -1 plus 4? And again, we know that it does. Let's move on to our second question. We're asked here to determine the number of solutions. Let's erase this. We're asked to determine the number of solutions here. Now, when I look at this problem, if you didn't do this one, go ahead and pause it and try it. When I look at this problem, I'm asking myself how many number of solutions it has, and I know the 3 options. It can either have 1 solution, it can have no solution, which again is when it has identical slope and different intercepts, or it could have infinite solutions, and that is when it overlaps one another. The lines interlap one another. So what do we have in this equation? I've given you all the options, and If you understand and you're picking up what's going on, you'll know that there is no solution. How do I know that? How can I be sure of that? How can I prove that? Well, let's go ahead and put it on the intercepts here. Let's make this one green, and let's make this one blue. Let's start with green. -1 is our intercept, and our slope is 3. So 1, 2, 3 over 1. So we're roughly there. We're going to connect those points. It's a pretty steep line. Again, that's a rough visual of it, but it'll do. All right, now our next intercept is at 2 with a slope of 3, an identical slope. So we go up 1, 2, 3, and over 1. So we're right about there. Right, let's connect from there, and let's extend up. Okay. So what you have here, and if this was a properly graphed line, it would look the exact same, going in the exact same direction. But what you'll notice is that these lines are parallel to one another. And in the math we know so far, parallel lines never intersect. And we know that the way we find an answer is when we have two lines that intersect. Well, these two never intersect, therefore you have no solution. Let's do two more. These will be more conceptual, explain them problems. Here's the third question. It's asking you to explain, in your own words, of course, why this system has infinitely many solutions. Go ahead and give it a shot, and I'd love to hear in the comments how you approach this problem and how you solved it and how you understand it. Okay, as I've warned you, you'll often be given these problems in a way where they're the same thing, but they look a little different. And that's what we have here. So we have y equals 2x plus 1. This one's good. This one is in linear form or slope-intercept form, so we can easily graph it. Now the second one's not, so we can't so easily graph it. So let's go ahead and manipulate it to put it in slope-intercept form. And what that's going to look like is we're going to divide every term by 2. And when we do that, we get y equals, after we make this manipulation to it, we get y equals 2x plus 1. Okay, very interesting, right? Now we have identical equations. And we'll remember that if the equations are identical, they have the same slope, they have the same intercept, those two lines overlap one another and therefore have infinitely many solutions. If I graphed it, I would graph it at the 1 intercept, and I would move over 1 and up 2, and I would do that for both equations, giving me the same line twice. Now, let me give you one more explain it type question to cement your conceptual understanding. All right, here's our final question. Go ahead, think about it, answer it in your own words. Leave a comment if you so choose. The question's asking, why might graphing not be the best approach for the system given here? And you'll see that they have decimals, they have decimal intercepts, they have decimal slopes. So they're definitely going to have an intercept, or almost certainly going to have an intercept that is a decimal itself, meaning it's not going to be at any neat point. Go ahead and try graphing this yourself. It's not fun. If you try to do it with your hand, and also if you did it with a application, it's just hard. Just not the best way to do it. And when we're learning math, we like to learn things that we can do by hand, with our mind, without the assistance of calculators, because that's where you get really understand things. So this question is going to lead us into our next unit, which is solving by substitution, and the unit after that is solving by elimination. And what that means is solving without using a graph at all, which is much faster, and in many cases, such as this, better. If you got something useful from this video, leave a like, a comment, or subscribe. Thank you, and keep getting better.